Welcome to Autism Mathematics. Thank you very much for always watching my videos. I just finished with a series, indices. I made 6 videos on indices. So if you are watching me for the first time, I will urge you to go back and watch those videos, or that will give you better understanding when we start this new series. Now the new series that I'm going to start is logarithm. Logarithm and indices are like twins. So let's start. Consider the following. The first one, 2 raised to the power 3 is equal to 8. And what does this mean? It means that 3 is the index or power to which the base 2 must be raised to get 8. Is that okay? Okay, number 2. 3 to the power minus 3 is equal to 1 on 27. So it means that minus 3 is the power to which 3, which happens to be the base, must be raised to obtain 1 on 27. So let's look at the definition of logarithm. So we can say that the logarithm of a number, say y, to a given base, written as log y, is the index or power or exponent to which the base must be raised in order to get the given number. For example, if y is equal to a raised to the power x, then by definition, log y to the base a is equal to x. That's all that we are saying. So, if you have p is equal to k to the power m, then log of p to the base k will be equal to its exponent m. So that's the definition. And let me remind you that if you have something like this too, you can write it in indices form. For example, if you have log z to the base a is equal to p, if you want to convert it to indices, so the number is equal to a to the power p. So that is the definition of logarithm. In indices, we saw some laws and rules and properties. In the same way, there are some laws and properties of logarithm that we are going to look at them, and this will help us to evaluate and simplify expressions involving logarithm. So laws or properties of logarithm. Remember, x, y are all greater than 0, and then the base a 2 is also greater than 0, and then must not be equal to 1 true. The first law, log of a number which is x to the base a plus log of another number y to the same base a is the same as you multiply those numbers to that base. So log xy to base a. Example, log 3 to the base 2 plus log 5 to the base 2. The bases are the same, so we can apply the laws. You multiply. 3 times 5 is 15. Let's come to the second law. Log x to the base a minus log y to the base a, where x and y are numbers. Then you can write it as log to the base a, x, the first number, divided by the second number. Example, log 5 to the base 2 minus log 3 to the base 2. Because they are subtracting, we divide the numbers. So log of 5 on 3 to the base 2. That is the second law. Let's look at the third law, which is power law. Now log x raised to the power n, that's log of a number exponent n to a certain base a. Then we can bring the power in front of the logarithm, making n log x to the base a. so we brought the n in front. Now let's check this. Log 3 to the power 2 base 5. We can rewrite it as bring the 2 in front and then log 3 to the base 5. Remember, these three laws, if you are at the right hand side too, you can break it to the left hand side. Yes, it's not always from left to right. So what I'm saying is 2 log 3 to the base 5, you can write it this way. The fourth law, we call it change of base. So on the left hand side, assuming that you want to change the base A to a certain base B, how do you do that? So log x to a base A. If you want to change it, then on the numerator, log x, the number to the new base, over log of the base to the new base. So log A to the base B. Yes. So that is it. There is a fifth law that is not here, and it states like A raised to the power log to the base A, let's say k. Now if you have something like this, the answer example, log 5 log to the base 5 x, and this is the same as x. Let's come to the properties. Log of a number to the base of the same number is always equal to 1. So log A to the base A is 1. So log 2 to the base 2 is 1. The second one, log 1 to any base is equal to 0. So example is log 1 to base 3. You can also have log 1 to the base 1000. This is still 0. So viewers, check these laws and properties very well, because that is what we are going to use. Or if you want to understand anything, you must know these laws. In fact, there are proofs for each of these laws, but I will not do them today. I just want you to know them so that we can use it to simplify certain expressions involving logarithm. So the next thing that we are going to do is to use these laws and properties to simplify certain expressions involving log. So let's look at examples. Simplify the following. The first one, log 12 to the base 5 plus log 10 to the base 5. So let's check base 5, base 5. The bases are the same. So since we are adding, according to law 1, we will multiply. So log 12 to the base 5 plus log 10 to the base 5 will be the same as log to the base 5 12 times 10, and this is the same as log to the base 5 120. So at this point we can't do anything about it, so we need to let it be. The second one, 2 log 9 to the base 7 minus log 81 to the base 7. So this is the same as, now per the power law, we can bring this one up. So we have log to the base 7, 9 to the power 2 minus log 81 to the base 7. And what is 9 to the power 2? That is log 81 base 7 minus log 81 base 7. Now from algebra, what is 2 minus 2? Which is 0. They are the same numbers or the same log. Log 81 to the base and log 81 to the base 7. Now at this point, you can subtract and get 0. And someone may decide to go further. Now when you go further, the bases are the same, so you just divide this. So log to the base 7, 81 over 81. And this is the same as 81 over 81. Is that not 1? Yes, 1. And what is log 1 to any base? this is 0. So either you end here or you continue, you still get the same answer. So let's look at other examples. So the other 3 examples are here. I want you to pause out. So number 3, we have 2 log 5 to the base a plus log 4 to the base a minus 2 log to the base a 10. Now this will be equal to, so power law, by the use of power law, we have log to the base a 5 squared plus log 4 to the base a minus, by the use of power law, we have log 10 to the base a. So by power law, this will be 10 squared, which will be the same as log to the base a 5 squared is 25 times 4 minus log 100 to the base a. This is the same as log to the base a 100, that is 25 times 4 minus log 100 to the base a. So the same thing that happened in the last but one example. So you can subtract and get 0, or you can say this is the same as log to the base a 100 over 100, and this is log to the base a 1. This is the same as 0. So for log x plus 1 minus log x squared minus 1. So if you want to simplify, now listen, logarithm without a base is assumed that it is in base 10. So this is also in base 10. So base 10, base 10. Log x plus 1 over x squared minus 1. This is the same as log, the denominator has difference of 2 squared, x squared minus 1. So we have x plus 1 over x plus 1, x minus 1. This x plus 1 will cancel this one. So you have log 1 on x minus 1. We can write this as log by, in indices, we can write it as x minus 1 all raised to the power minus 1. And by power law, and bring it as minus 1 log, so log 125 over log 5. Care must be taken with this kind of question. Look at it carefully. You can apply the laws here. Well, this is log 125 divided by log 5. So we can use power law to simplify this. So log 125 can be written as log 5 raised to the power 3 over log 5. And by power law, we bring it forward. So 3 log 5 on log 5. So that this can cancel that, and we'll be left with 3.